History tells us that humanity is the first and only industrial civilization to ever walk the Earth. We look at our soaring skyscrapers, our satellites, and our digital footprints, and we assume that such a monumental impact on the planet could never be erased. But if we look at the vast yawning stretches of geological time, hundreds of millions of years, before the first primate ever stood upright, a chilling question emerges. If an advanced industrial species existed 60 million years ago, would we even find their ruins today? This is the Silurian Hypothesis, a scientific thought experiment. It suggests we might be walking on the dust of a forgotten predecessor. The problem is the sheer power of Earth's natural cycles. In less than 1 million years, wind, rain, and tectonic shifts can grind cities into unrecognizable silt. Our roads would be swallowed by forests. Our plastics would eventually degrade or be buried under kilometers of sediment, and our bones would dissolve in the shifting chemistry of the soil. If a species like ours lived during the Paleocene epoch, their achievements would be a thin layer of carbon, buried deep beneath the ocean floor. We aren't looking for ruins. We are looking for a ghost in the chemistry of the world. To find them, we have to look for the technosignatures that time cannot erase. We look for sudden, unnatural spikes in carbon and oxygen isotopes, or the presence of synthetic chemicals that don't occur in nature. When scientists looked at the transition between the Paleocene and the Eocene, they found exactly that, a massive, mysterious warming event known as the PETM. For a brief moment in geological time, the planet's temperature skyrocketed, and the oceans acidified, driven by a sudden release of massive amounts of carbon. Was it a volcanic eruption, or was it the exhaust of a civilization that burned through its fossil fuels 56 million years ago? The deeper we look into the Earth's past, the more we realize how brief the human era truly is. We are a mere heartbeat in the life of the planet. If the Silurian hypothesis is true, it means we are not the masters of Earth, but merely the latest tenants in a house that has seen many guests. As we begin our journey into this prehistoric mystery, we must ask ourselves, if we are destined to vanish like those before us, what mark will we leave behind? And who will be the next species to wonder if they were the first? If you want to leave a message for a civilization 10 million years in the future, don't build a monument of stone, don't write a book, and don't build a digital server. In the relentless machinery of Earth's geology, those things are as fragile as a spider's web. To truly endure across the eons, you need to change the very chemistry of the planet. This is the plastic fossil theory. In the far future, the most enduring legacy of humanity won't be our art or our philosophy. It will be a thin, multicolored layer of synthetic polymers, microplastics, and radioactive isotopes baked into the sedimentary rock. To a future geologist, we will be known not by our names, but by our waste. This realization leads to a haunting question for those hunting the Silurian hypothesis. What did our predecessors leave behind? If an industrial species existed 50 million years ago, they wouldn't have used the same plastics we do. Their chemistry might have been based on elements we haven't even considered. We are looking for technosignatures, anomalies in the rock that simply shouldn't be there. Perhaps it's a sudden, concentrated spike of rare earth metals in a single geological layer, or a strange concentration of processed isotopes that suggest a nuclear age that happened before the dinosaurs even took their first breath. The deeper we dig, the more ghost signals we find. In certain deep-sea sediment cores, scientists have discovered layers of charcoal and soot that date back millions of years. Usually, these are attributed to massive forest fires or volcanic activity. But when you look closer, the carbon isotopes in some of these layers bear a striking resemblance to the exhaust of an industrial society. It is as if someone eons ago discovered the power of fossil fuels, built a global infrastructure, and then suddenly stopped. The Earth has a way of recycling itself, pulling the crust down into the mantle and melting the evidence of our greatest sins. But there is one place where the plastic fossil might remain untouched: the Moon. Unlike the Earth, the Moon has no wind, no rain, and no tectonic plates to swallow the past. If a pre-human civilization ever achieved even the most basic spaceflight, their footprints are still there, sitting in the lunar dust, waiting for us to find them. If we want to find our older brothers, we might need to stop looking down at the dirt and start looking up at the stars. Because on Earth, the clock is always ticking, and the planet is an expert at hiding its secrets. 56 million years ago, the Earth underwent a violent transformation that geologists still struggle to explain. It is known as the Paleocene-Eocene thermal maximum, or the PETM. In a geological heartbeat, global temperatures skyrocketed by 5 to 8 degrees Celsius. The oceans acidified, coral reefs collapsed, and the poles became tropical swamplands. Palm trees grew in the Arctic Circle. For decades, the consensus was that a massive volcanic eruption or a sudden release of undersea methane caused the chaos. But when we look at the isotope signature of the PETM, a much more disturbing possibility emerges. The carbon spike from 56 million years ago looks almost exactly like the carbon spike we are creating today. If you were a scientist from the far future looking back at the human era, you wouldn't see our cities or our internet. You would see a sharp vertical line in the carbon record, a sudden burp of ancient carbon. This carbon was dumped into the atmosphere over a period of just a few thousand years. This is precisely what we see in the PETM. The isotopes show a massive injection of light carbon, the kind typically found in organic matter or fossil fuels. If a pre-human industrial society existed, their global warming event would look identical to a natural volcanic disaster. The Earth doesn't distinguish between a volcano and a coal-fired power plant. It only records the heat. What makes the PETM so haunting is how long the effects lasted. After the initial carbon spike, it took the Earth nearly 200,000 years to recover and return to its original temperature. If there was a Silurian civilization that triggered this event, they didn't just disappear, they likely collapsed. They collapsed under the weight of the very climate they broke. In the fossil record of that era, we see a massive migration of species and the sudden appearance of dwarf mammals. Animals shrunk in size to survive the stifling heat. We see life struggling to adapt to a world that changed too fast to handle. Could the PETM be the exhaust of a global empire that lived, thrived, and died millions of years before the first apes appeared? We have no ruins of their factories, no fragments of their steel, and no record of their names. All we have is a fever, a global spike in temperature that suggests someone or something was burning through the planet's resources at an industrial scale. If the Silurian hypothesis is correct, the PETM isn't just a curiosity of ancient history. It is a warning. It is the ghost of a civilization that flew too close to the sun and left behind nothing but a layer of ash, and a planet that took 200,000 years to forgive them. If you want to hide a global empire, there is no better place than the bottom of the ocean. But the sea is not just a graveyard, it is a recycling bin. One of the most frustrating obstacles for those testing the Silurian hypothesis is a process called subduction. The Earth's tectonic plates are in constant, agonizingly slow motion. The oceanic crust, where ancient coastal civilization would have flourished, is pushed beneath continental plates and dragged into the white-hot mantle. Every 200 million years, the entire floor of the ocean is completely renewed. It is melted down, turned into magma, and erased. This means that if a species like ours built sprawling megacities 60 million years ago, their foundations have been incinerated. We are looking for needles in a haystack where the haystack is constantly being burned. To find the deep-sea graves, we have to find the rare pockets of ancient seabed that have survived. These are the abyssal plains, stagnant regions of the ocean floor where sediment has piled up undisturbed for eons. Here, the history of the world is written in layers of falling organic snow and volcanic ash, and perhaps the chemical runoff of a forgotten industrial age. In these deep-sea cores, we find anomalies that defy easy explanation. Occasionally, we find spherules, tiny, microscopic glass beads that are usually the result of a massive meteor impact or a nuclear explosion. While most are linked to known cosmic events, some appear in layers that don't match any known craters. Are these the remnants of ancient power plants, or the fallout of a prehistoric conflict we can't even imagine? The ocean hides its secrets well, but it also preserves them in the form of Lagerstätten, extraordinary fossil beds, where even soft tissues and delicate structures are preserved in fine-grained mud. The haunting reality is that we have only mapped 5% of the deep ocean floor. We know more about the surface of Mars than we do about the abyss of our own planet. Under kilometers of crushing water and millions of tons of silt, there could be entire techno-fossil fields, ruins that are no longer recognizable as buildings, but as strange, geometric patterns in the rock. Ghostly outlines of a world that looked just like ours. As we develop more advanced deep-sea submersibles and sonar mapping, we are beginning to peer into these graves. We aren't just looking for bones anymore. We are looking for the machines that lived before us. If the Silurian hypothesis is true, it changes the very definition of what it means to be human. We are no longer the protagonists of Earth's story. We are merely a single chapter in a book that has been written and erased a dozen times over. This is the eternal cycle, the idea that intelligence is not a final destination, but a recurring biological phenomenon. Perhaps every few million years, conditions become just right for a species to climb out of the mud, discover fire, harness the atom, and build a global empire, only to be swallowed by the very planet that birthed them. We look at the silence of the stars and call it the Great Filter. But perhaps the filter isn't in space. Perhaps the filter is right here beneath our feet. We often wonder why we haven't found alien life in the cosmos, but we rarely ask if we are the first aliens to live on Earth. If civilization is a cycle, then the Silurians of the past are our true ancestors. They faced the same climate fever we face today. They looked at the same moon and wondered if they were alone. And like us, they likely believed they were the pinnacle of existence, the masters of time and space. But the Earth is a patient goddess. She does not care for our monuments or our digital clouds. She waits for the ice to return, for the plates to shift, and for the sun to bleach the remains of our pride into white dust. The most haunting realization of the Silurian hypothesis is what it says about our own future. If we vanish tomorrow, whether through climate collapse, nuclear fire, or simply the slow march of time, what will remain of us in 60 million years? A future species, perhaps evolved from birds or octopuses, will dig through the rock and find a strange, anomalous layer of processed carbon and radioactive isotopes. They will look at the graphs, see the sudden spike in temperature from the 21st century, and they will ask the same questions we are asking today. Was someone here before us? Did they have names? Did they have dreams? And why did they disappear? We are not the first, and we will not be the last. We are part of a grand planetary heartbeat, a cycle of rise and fall that stretches back to the beginning of time. Our mission now is not just to survive, but to leave a message that can survive the fire. To be the first civilization that breaks the cycle, that leaves the cradle of the Earth and plants its seeds among the stars, where the geology of a planet cannot reach them. Until then, we walk among the ghosts of 1,000 forgotten empires, breathing the air they once breathed, standing on the dust of their cities, and waiting for the Earth to turn the page once more. The story of life is long, and we are just beginning to realize how many voices have already spoken.